So the first thing to fix is that the top left should say class notes. Sorry about that. I want you guys to see that when it comes to adding and subtracting radicals, and this is really what this is all about, we can only do it if they have like radicands. Like radicands mean the same thing under the radicals. We're looking for like radicands and we're looking for like terms, just like we would with variables. Number one, I want you to see that as be the same thing as having 8x plus 2x. You guys should know 8x plus 2x is 10 times x. This is 8 times radical 11 plus 2 times radical 11. In essence, if I really wanted to, and I'm not going to, but if I really wanted to, I could factor out a radical 11, leaving behind 8 plus 2. 8 plus 2 is 10, even Max Chalice knows that. So we have 10 times radical 11. You don't have to go that far. All you would have to do would be to show that you recognize that 8 radical 11 and 2 radical 11 have like radicands, and that they can be added that way. Just go directly to 10 radical 11. So if I look at number 2, we sometimes use the underlining strategy to identify like terms. The radical 3s I'll underline in one color, and the radical 2s I'll underline in a different color and twice. And I'm going to look at the coefficients. 7 minus 1 is 6, 6 radical 3. Then I have 2 minus 3 is negative 1, so that gives me negative radical 2. And that can't be simplified anymore. For number 3, sometimes we may have to simplify the radical before we do anything. So if I simplified radical 80, well, at least broke it apart for now. 80 is 16 times 5. Then I have minus 12 radical 5. 16 can come out as the square root of 16, which is 4, and 4 times 5 is 20. 20 root 5 minus 12 root 5. 20 minus 12 is 8, and so I have 8 root 5. For number 5, I have 25 radical 2, which is simplified, plus 2 radical 27. Okay, that's 2 times 9 times 3, minus 3, and radical 98. 98 is 49 times 2. So some of that stuff's going to be able to come out, like the 9 can come out and the 49 can come out. And we get 25 radical 2 plus, let's see, 9, square root of 9 is 3. 3 times 2 is 6. 6 radical 3 minus, and then 7 times 3 is 21. And I have 21 radical 2. Look for your like terms, and we have 21 and 2 gives us 4. 4 radical 2. And then plus 6 radical 3, because those aren't like terms. They don't have like radicands, and they can't add. Oops. Okay, next one. We're going to look to simplify these as well. Got negative 4 radical 2 plus 6. 72 I can break up into 36 times 2 minus 8. And 32 I can break up into 16 times 2. I have negative 4 radical 2 plus 36 comes out as 6, and 6 times 6 is 36, still with the radical 2, minus 16 comes out as 4, 4 times 8 is 32, radical 2. If I add up the coefficients, I have negative 4, 36, and negative 32. That would be 32 minus 32, so you get 0 radical 2, or just 0. 6, I have 4. Radical 1, 12. I know that's going to be divisible by 4 because the last two digits are divisible by 4. So I could break it up into 4 and 27. Is it? No, it wouldn't be 4 and 27. 4 and 28. There we go. That's what I'm thinking of right now. Yeah, does that work? Yep. 4 and 28. Then 5 and 56. 56 is 28 and 2. 56 is also, let's see, 14 times 4. So let's just do it as 4 times 14. And then 126, I can break it up into 63 times 2. We can leave it like that for now. Well, let's see, we have 4 and 28. I know that can really be 4 times 7, 5 radical, this would be, well, I can take this out now. That can multiply to become 10, leaving behind a radical 14. And then 63 is 9 times 7, so I have 9 times 7 times 2. That can multiply. Those can come out. So 4 times 2 times 2 is 16. So I'm going to 16 root 7, plus then I have 10 root 14, minus 3 times 9 is 27 root 14, because 7 times 2 is 14. I can combine these. I have 16 radical 7. 10 minus 27 is negative 17 root 14. Moving over to back, we now have problems with fractions. We have to simplify the fractions before we go. Radical 3 minus radical 1 over radical 3, which is radical 3 minus 1 over radical 3. Now, this radical 1 over radical 3 I need to rationalize to make rational. Rationalize the denominator. So I'm going to multiply it by a radical 3 over radical 3, and that's going to get me radical 3 minus, I have radical 3 over 3. Now I need to add these with an LCD. Here it would be 3. So this one gets multiplied by a 3 over 3. And if I kind of move this up here, that would make that first one be 3 root 3, and then I have minus root 3 all over 3. And then 3 root 3 minus root 3 is 2 root 3. So my final is 2 root 3 over 3. Let's try this again. Number 8, I'm going to simplify this radical. So if I take out a 25 and multiply it by the 2, I get 10, leaving behind the 3, because 25 times 3 is 75, plus, and I have radical 3 over radical 16. That's 10 root 3 plus radical 3 over 4. So I'm going to multiply this first one by a 4 over 4 with an LCD of 4. Remember, I'm writing my LCD. To make that, then that would be 40 radical 3 plus this radical 3 all over 4. 40 plus 1 is 41, so that's 41 radical 3 over 4. Number 9, if I do the distributive property, 5 times 4 is 20, 2 times 8 is radical 16, which is a perfect square. Then 5 times 2 is 10. I'm going to leave the rest of this factor, 2 times 12, that's 2 times 2 times 6. This comes out as 4 times 20 is 80, minus, this comes out as 2 times 10 is 20, radical 6. Next one, 4 times 2 is 8, 3 times 15, I'm going to leave it as 3 and factor the 15 into 3 times 5, plus 4 times 1 is 4, and then the radical part, we're going to have is 3 times, and 48 is 3 times 16. See, the 3's are going to come out as 3 times 8 is 24, radical 5 stays. And these 3's come out, and the 16 comes out as a 4, so we have 4 times 3 times another 4, which is 16 times 3, or 48. Number 11, we've got some simplifying to do. We have 3 radical 5 over radical 12 plus radical 12 over radical 5 minus, then I have radical 60 over 3. So I'm actually going to need a lot more space for this one because we have to simplify some radicals. Remember, 12 is 2 radical 3, so I have 3 radical 5 over 2 radical 3 plus 2 radical 3 over radical 5, then minus 60 is 4 times 15, so that's 2 radical 15 over 3. What I could do is rationalize each part, so let's take this first one and multiply it by a radical 3 over radical 3. Let's take this second fraction and multiply it by a radical 5 over radical 5. So I end up with 3 radical 15 over, this denominator would be radical 3 times 3 is 3, times the 2 is 6, plus, then I have 2 radical 15 over 5, minus, and I still have 2 radical 15 over 3. Should be able to look at the 3 and the 6 and cancel those, so we get radical 15 over 2 plus 2 radical 15 over 5 minus 2 radical 15 over 3. And we're going to go in LCD with the 2, the 5, and the 3, and that would be 30. So if that's 30, then this first one needs to be multiplied by 15, so that's 15 radical 15 plus, and then 6 times 2 is 12, 12 radical 15 minus 10 times 2 is 20, radical 15, all over 30. 15 plus 12 is 27, minus 20 is 7, so then we have 7 radical 15 over 30. Next, I'm going to rationalize this one with a radical 3, but you know what, I should simplify first. Let's make this 2 minus 12 is 2 root 3 over root 3, multiply by radical 3 over radical 3, and distribute. And I get 2 radical 3 minus, and this is 2 times 3, so minus 6 over 3. Now, I could factor a 2 out of the numerator and make that 2 radical 3 minus 2 over 3, but I still can't cancel anything. So you can either write this or write this as your final. Finally, number 13, if I rationalize that by multiplying by a radical 6 over radical 6 and distribute, I get 2 radical, that'd be 3 times 3 times 2, because 6 is 3 times 2, plus 5 radical 2 times 3 times 2, over, then 6, because radical 6 times radical 6 is 6. So this 3 is going to come out and give me 6 radical 2. These two 2's are going to come out and give me 10 radical 3. That's going to be all over 6. This one can factor. If I take a 2 out of the numerator, I get 2 times 3 radical 2 plus 5 radical 3 over 6. And those are going to cancel. And my final is going to be 3 radical 2 plus 5 radical 3 over 3.